Hey guys, Buildzoid here, and today I'm going to be doing a video that I don't really feel like doing, but I keep getting questions about this on live streams, so here we are. Regarding the 13th gen, 14th gen instability problems, so this primarily affects i9s and some i7s, right? And basically the issue is that some Intel like 13900Ks, 14900Ks, 14900KS, 13900KS, 13 not 13700K. I'd be really surprised if a 13700K had a problem, but a 14700K you might find will just sort of crash under high load scenarios. Why is and it's not all of these CPUs, it's some of these CPUs. So yeah, some of them will just crash under high load. And this has become such a big problem now that like we even have NVIDIA basically saying like if your system is using a Intel 13th gen, 14th gen unlocked desktop CPU and it's experiencing stability issues, out of video memory errors, crashes to desktop while the game is compiling shaders, because shader compilation does potentially hit the CPU with 100% load. Please consult the following sites, and then it points us over to this Intel like community forum post and Rad Game Tools article over here. Rad Game Rad Game Tools is a like software game software developer, and Oodle is like an asset decompression tool primarily for Unreal Engine. And basically this is, you know, like it decompresses assets and it uses the CPU to decompress the assets, and since it's pretty well, you know, optimized software, it can actually use all of the CPU to do that, and then it'll crash if you have a unlucky 13900K, 14900K, 13700K, 14700K. And then this article from the actual like developers of Oodle recommends that you basically, if nothing else, like set the power limits to what Intel recommends. And then if that still doesn't help, then just straight up manually underclocking the CPU. Right? And so, first things first, so basically we have like Intel CPUs crash. A lot of like gamers just find out that they crash when you run Unreal Engine. Other people who might do like 3D rendering or scientific compute workloads will find out that actually the CPU just crashes trying to render things or do like high, like all core, workloads of basically any kind. Well, a variety of kinds. Because the funny thing with this, at least in my experience, is like I have a 14900K that actually will not run Cinebench on out-of-box settings. So if I clear CMOS, that CPU will just crash in Cinebench. It takes anywhere from like 10 to 30 minutes for it to crash running Cinebench on auto settings, and this happens on both Asus motherboards and Gigabyte motherboards. So, it's just not stable on the like out-of-box configuration for those boards. So I have the CPU that's unstable, but the funny thing is it will actually run Prime 95 small FFTs. It'll run YCruncher, VST, VT3. So it'll actually run workloads that pull significantly more power than Cinebench, at least if the CPU wasn't thermal throttling. So the reason that, my theory as to why it specifically crashes in Cinebench and doesn't crash in, say, Prime 95 small FFTs is that when that CPU is running Prime 95 small FFTs and it's thermal throttling at 100 degrees Celsius, Prime 95 runs at like 5 gigahertz, whereas Cinebench runs at like 5.4 gigahertz. Right? So Cinebench is crashing because at 5.4 gigahertz and 100 degrees Celsius, it's not getting enough voltage. Prime 95 small FFTs isn't crashing because at 100 degrees and 5 gigahertz, it is getting enough voltage. Right? Because really the only reason a 13th gen or 14th gen CPU will crash in my experience is that the core voltage isn't high enough. Because if you're manually overclocking a 13th gen or a 14th gen CPU, you can run even above 100 degrees and still be stable as long as the voltage is high enough. So like if you want to run, say, 5.5 gigahertz at like 110 degrees because you're running some incredibly heavy all-core workload, you just need to set the voltage high enough for that to work. And there is a voltage at which it will work. Now, is that safe for the long-term health of the CPU? I don't know. I am not a, like, I don't, I don't know. I don't have the, like, reliability data that Intel has for their CPUs. So that's probably not safe for the CPU, but in the short term, you can at least get it stable. So with the 13th gen, 14th gen CPUs at 100 degrees Celsius, if the CPU is crashing, it just needs more voltage, right? Like, that's it. Like, if you want to just, if you don't really care about anything else and you just want to fix the crashing problem, you can literally just raise the core voltage and that will eventually stop the CPU from crashing. So basically the problem can be summed up as at 100 degrees Celsius, for certain parts of the frequency table, the CPU some CPUs don't get enough voltage and then they crash. But there's a few different ways to fix it. So one way that I just described is you can raise the voltage. And on ASUS, like changing the SVID behavior to Intel failsafe will actually increase the operating voltage of the CPU. On Gigabyte motherboards, if you like raise there's like a load line calibration setting that you have when you're on the stock like vid functionality. You can change that from like auto to like say ultra extreme, and that'll increase the operating voltage under load. Now, the funny thing is when you also increase the operating voltage under load, if the CPU is thermal throttling at 100 degrees and you give it more voltage to try fix the stability, it'll actually downclock more. So the frequency will actually come down, which further helps with the stability because you're just running a lower frequency at a higher voltage. So that's more stable than a higher frequency at a lower voltage. So, yeah. So that's one way you can fix this, is if you don't care about the fact that like the CPU is thermal throttling and pulling more than the recommended amount of power by Intel, yeah, you can actually just raise the voltage and that'll basically fix the stability problems. Now, how much you need to raise the voltage, that'll depend on the specific CPU. On some CPUs, you don't need to raise it at all, and because there are chips out there that just don't crash out of the box, right? And some of them do. And if you have one that does, then more voltage will fix it, probably. Alternatively, you could also just set the power limits to what Intel actually recommends. So like 253 watts for both PL1 and PL2. If you have a 150 watt CPU, if you have a 125 watt, you could set it to 125 and 253 watts. And the thing is, what this will do is this won't raise the voltage at 100 degrees Celsius, but it'll make the CPU power throttle so much that it'll probably not hit 100 degrees Celsius anymore. This does work for my 14900K. Like I've tried this. Setting like both PL1 and PL2 to 253, that fixes the Cinebench crashing for me. The other thing I tried was also raising the voltage. That also fixed the Cinebench crashing for me. Yeah, so to me, like, why does this happen? The CPU just doesn't get enough voltage. Like, there's really, like, it's not complicated. CPUs crash because either they're way too hot or the voltage is not high enough. With Intel chips, way too hot isn't really a factor because they will scale with voltage all the way to like over 100 degrees Celsius. So logically, the only issue here is the voltage isn't high enough. Now, you know, if you set the power limits, the CPU will power throttle before it thermal throttles, and so you're going to run at like somewhat lower frequencies, and it'll not crash because it's running at lower frequencies at lower temperature because it's thermal throttle, like it's power throttling before it hits the thermal throttle point. So that's a few different ways to fix it. If you're really unlucky, even just like setting the power limits to the Intel recommendations won't be enough, in which case, again, you might just have to raise the core voltage. And I guess if you're really, really unlucky, you might even have to underclock the CPU like full on by lowering the CPU ratio. But I think if you're at that point, you should just tell Intel to replace your CPU because that, like, if you can't, like, if the CPU doesn't function on the, like, Intel recommended power limits, I would say that CPU is just straight up defective at that point, right? Like, that is just, like, it's defective. Get Intel to replace it. Anyway, also, I want to point out that you'll notice this table is labeled recommended value, not specified, not required, not maximum value. It's recommended. This is why motherboard manufacturers will punch whatever power limit into the BIOS they feel like, because Intel is totally cool with it. Because Intel makes a recommendation, and because it's a recommendation, the motherboard vendors read the recommendation, and then they throw it in the bin. And Intel's fine with that. Because if Intel wasn't fine with that, they would specify that the power limit has to be these numbers. But they don't. Anyway, so, yeah, that's why the power limits get just set to, like, arbitrary values by the motherboard manufacturers. And then, yeah, so that's the first thing, is, like, the power limits are whatever the motherboard vendors feel like, because Intel is actually just totally cool with that. AMD, for comparison, isn't cool with motherboard manufacturers punching in whatever power limit they feel like. And so if you take a 7950X and you put it on literally any AM5 motherboard, the PPT, EDC, and TDC are all set to the exact same numbers on every single motherboard. The PPT is always 230 watts, and the I can't remember what the EDC is set to, but actually I think the EDC might be always set to 170 amps. But the main current limit for the 7950X is always set to 170 amps. The power limit is always set to 230, and that is on every single motherboard, because AMD actually specifies power limits. Intel recommends them. For comparison, also, like, NVIDIA doesn't have problems with GPU manufacturers cooking up whatever power limits they feel like, because NVIDIA specifies a power limit. And also, if you violate NVIDIA's recommendations, NVIDIA will just not sell you GPUs anymore. And then you, like, potentially that is a big problem if, you're a GPU manufacturer and you primarily sell NVIDIA GPUs. Not getting chips from NVIDIA, pretty bad. So, yeah, like, I'm actually, like, kind of surprised that, like, no AMD motherboard vendor hasn't gone ahead and, like, tried to mess with the AMD power limits. To be fair, on AMD motherboards, like, one potential way of, like, getting around the power limits is if the voltage regulator isn't very good at measuring the output power, then that'll, like, mess with the power limits. I'm pretty sure even with Intel CPUs, that's a potential way of, like, messing with the power limits from the factory, but that's not really, like, that, like, I've never seen a motherboard vendor intentionally do that. On AM4, there are some motherboards where the power monitoring just isn't very accurate due to the power delivery circuitry not being very good. But there's no, like, I can't think of any example where a motherboard manufacturer went, like, out of their way to try violate the AMD power limits. Whereas with Intel, like, you don't have to do anything to violate the Intel recommendations, because they're recommendations. You just ignore them. That's how that works. Anyway, so since then, Asus has actually put out a BIOS update for some of their motherboards that adds a Intel baseline profile, which basically enforces the Intel power limits, and then also sets the SVID behavior to Intel failsafe, which gives you a ton of extra voltage, which should basically ensure that the CPU never ever crashes. That's why it's called failsafe. The bad news about this is it does give you an absolute ton of voltage, and the upper limits of the operating voltages according to Intel is up to 1.72 volts. But I have doubts about this actually being safe for long-term use. And I say that I have doubts about this being safe for long-term use because I know for a fact that for some older CPUs, this is definitely unsafe, even though I think for like 10th gen already, the documentation has a maximum operating voltage of 1.72 volts in the documentation, and those CPUs, like, they will degrade if you try to run that much voltage on them. So yeah, I don't think this is actually safe, and the Intel failsafe settings will potentially end up at this, for like idle, because yeah. Anyway, where was I going with this? Right, so we've sort of covered the like basically the stability problem is just like the CPUs aren't getting enough voltage, and then there's like a bunch of different ways that you can try to fix, like, not enough voltage for the frequency they're trying to run at. Basically, all of the fixes devolve into if the CPU, like, any of these things you do, like lowering the power limits, increasing the operating voltage. Actually, one thing you could also try if you don't want to mess with the power limits or the operating voltages is you could just set a lower thermal limit. If you set the thermal limit to 85 degrees, the CPU will, again, clock itself lower because it's going to hit 85 degrees long before it hits the, like, power, like, thermal limit. Well, like, it's just going to end up on, like, clocking the CPU lower to stay below 85 degrees Celsius. But that would also fix the instability, right? Because, again, at lower operating temperatures and lower frequencies, you need less voltage to maintain stability. So that would work. So we've covered all of that, I think. We do actually, what I do find kind of interesting is that for the currents, we do actually have, like, a kind of a specification. So I'm kind of surprised that the motherboard vendors get to ignore that too. Because, yeah, like, I don't think I've ever seen a motherboard actually set these to the numbers that are in this data sheet over here. So I don't know, but the thing is like, well, Intel doesn't care about the power limits being set to whatever they recommend. So like, do they also not care about the current limits? Probably, because like, if they did care, they could like, they're Intel. Like, if you are Intel motherboard manufacturer and Intel tells you to do something and you don't do it, I imagine you'd get into pretty serious trouble with them. So, um, like, the only way I can see that like a motherboard manufacturers are cool, like Intel is cool with motherboard manufacture, like with motherboards shipping with basically no current limits, is that Intel is cool with motherboards getting shipped with no current limits. Because the other option is that Intel simply doesn't test their like partner products at all, right? Which actually wouldn't surprise me based on this comment right here. We're engaged with our partners and conducting analysis because like, I don't bin Intel CPUs myself, but I have talked to people who build like, or who do bin Intel CPUs, or build a lot of systems with Intel CPUs. So they go through like quite a few 14900Ks, multiple 14700Ks, that kind of thing. And from talking to those people, it's really not that rare that you would get a 14700K or a 14900K where after a clear CMOS, so the out-of-box settings on the motherboard, it won't run Cinebench. Like, that's apparently not very rare. So if you're Intel and you're conducting analysis, why haven't you, like, I don't know, gone and like bought a retail motherboard? Because I'd be kind of suspicious that, you know, maybe the board partners send Intel motherboards that have like actually enforced power limits on them. So don't go asking the board vendors just in case they're like messing with the samples that they're selling you or like sending you. Go buy a retail motherboard, take 100 random CPUs out of the production line, put them in that retail motherboard, try to run Cinebench. See what happens. Chances are, quite a few of them won't run Cinebench. I don't know how much more analysis you need to do past that. Because as far from what I've heard, even if you took like 20 random CPUs, you would probably find a couple that struggle at high load. So I don't know how Intel isn't aware of this. Like, to me, this seems like either they don't, like, maybe they don't test Cinebench, maybe they only test Prime 95, or maybe they have some internal Intel stress test tool that's the only thing that they test, and which is still concerning because, like, what kind of freaking, you know, validation is that? Like, if, like, as far as I'm concerned, a stability, the most like absolute definition of stability is the CPU is able to run arbitrary valid code, and the reason it needs to be valid code is obviously if somebody writes code that crashes, then it's not the CPU's fault when, you know, the program is trying to do something that causes a crash. But if the software isn't doing, like, if the code is valid, the CPU should be able to run that indefinitely. Okay? And Cinebench runs on most CPUs, except for some 14900Ks and some 14700Ks and some 13900Ks. And if you're Intel, I don't see why you wouldn't be able to just take like 100 14900Ks and just run them on out-of-box settings on one of your board partners' motherboards and see what happens. You're going to have several of them not able to run. Like, it's just not going to work. This isn't exactly difficult to test for, in my opinion. You don't even need to, like, so this, like, so based on, like, I kind of feel like they just don't test this, apparently. So, yeah, and I guess if they can't be bothered to do even that much validation, then I guess they don't know that most motherboards don't have a current limit on them. And then we get to have, you know, like NVIDIA in their driver notes mentioning that, hey, the CPUs, like, some of them crash sometimes. So, yeah, like, so to me, like, this whole situation is just incredibly disappointing from the perspective of, like, does Intel do any testing on, like, real-world motherboards at real-world settings? Because, like, if you go down to, like, yeah, like you could you could probably go to like Amazon or Newegg or and just like buy a bunch of CPUs and like one motherboard, and chances are a bunch of those CPUs aren't going to run Cinebench, and probably even more of them aren't going to be able to run Oodle, because I've heard from some people that apparently this is more difficult to be stable in than Cinebench is. Um, so like, and like so basically you'd like try to launch an Unreal Engine game and see if see how many of the chips can't even do that, I guess. Um, which is, I guess you would have to like wipe the shader cache every time in between tests, because obviously after the shader's compiled once, it's going to work on every like it's not going to have to recompile them. Um, but yeah, like this to me just seems like a total validation failure. Like how do you not notice this? Because like I got somebody actually tweeted a video of their 14900 KS at me, where they got a brand new 14900 KS. They put it into, I think, an MSI motherboard, clear CMOS, right? So BIOS is completely set to like like auto settings, like out of box configuration. Um, and then they go to try run Cinebench, and it just instantly errors out. Like, it doesn't even try to run Cinebench. They press run, and it just spits out an error message. Right? And then they, like, show how if you underclock the CPU, it works. It's like, yeah, because like that CPU came from the factory with a vid table that doesn't have enough voltage to run Cinebench without power limits. Which is like... And then, of course, you have CPUs like my 14900K, which isn't like also can't run Cinebench, but it's not to the level of like I press run and get an error. I press run and 30 minutes later I get an error, or 10 minutes later. It kind of varies. And so, yeah, like this is like do they do any testing? Or do they only test the top 1% of chips or something? Because that's the thing is like each 14900K ships with a different vid table, and some of them are really bad. And I imagine those are the chips that are like failing all of these scenarios. Is like you get a 14900K that's in the bottom 10% of the production run, and it just doesn't work at high load, right? Because the vid table just isn't stable at 100 degrees Celsius, right? And so then you can fix it by either like lowering the power limits or increasing the operating voltage by messing with the load line calibration settings, or by actually doing a positive offset, like just plus 30 millivolts or something. On some chips that'll be enough to fix this. Or you can underclock the CPU by lowering the ratio, or like, but these are all things like where it's like did they never, like, do they test, like, how did this get out of the factory? That's the thing I don't get. How does that chip that like crashes Cinebench instantly, how did that walk out the door of the factory as a 14900 KS? Because that's just a complete freaking validation failure, in my opinion. And then Intel's like, oh yeah, we're totally unaware of this? And it's like, what? How? It's not even rare. Anyway, so like I'm incredibly just like disappointed with this whole situation, because it's like this isn't hard to test for. How do they not know about this? Why has it taken so long? And to be fair, this isn't the first time we've seen a manufacturer like screw up their stock CPU configuration, and I am entirely blaming Intel for this, by the way, because like, look, if Intel wanted motherboard vendors to ship with a power limit, they wouldn't recommend it, they would require it. And well, that's basically most of it, really, on my part. But so, like, because I've seen a lot of people blame the motherboard vendors, but like, the motherboard vendors do what is, what they would do. And AMD has no problems enforcing power limits. NVIDIA has no problems enforcing power limits. But Intel apparently can't figure out that like X% of their CPUs can't run Cinebench on out-of-box settings. What? But anyway, this isn't the first time this has happened. May I remind you that AMD with Ryzen 3000, right, there was like a lot of the early 3000 series chips would basically never hit their max boost frequency, right? So you'd get like a 3950X, which is advertised as an up to 4.7 gigahertz CPU, and like 99% of the time the chip would never go over like 4.6 or something, right? And there was actually like some variance from motherboard to motherboard what kind of max boost frequencies you would see. So like that, but the difference there, I guess, is that AMD's boost algorithm isn't stupid enough to crash the CPU, right? So if you had like a failing 3950X that wasn't up to that 4.7, like wasn't really up to that 4.7 spec, it would just run at 4.6, which admittedly like sucks, right? Because you buy a 4.7 gigahertz rated CPU and then it only runs at 4.6. Like that's not great. But at least it didn't crash. So if you were using it for like rendering or something where it wouldn't be hitting that single core boost anyway because the rendering workload is all core, you wouldn't have like, like you'd start like a render if you're like a 3D artist or something. You start a render and then you come back the next day and it's like the render didn't finish because it crashed. Like that wouldn't happen with AMD's boost algorithm. NVIDIA had that thing with early like 3080s, 3090s where like the boost was too aggressive, so the cards would like randomly crash sometimes. And NVIDIA fixed that by putting out a driver update that just made the boost clocks a little bit less aggressive. Right? So this isn't the first time that we've had a manufacturer like run into this kind of issue, but I'm surprised it took this long for them to like make a response about it. And then like the fixes for this are like still like this is a mess. Like Nvidia was just like here's a BIOS, like here's a driver update, bam, 30 series crashing stopped, right? That was the issue that was originally like blamed on the capacitors. And so NVIDIA just like put out a driver update, slightly lowered the boost clocks, and it like there, And I think it lowered performance by like 1 or 2%. And it's like, yeah, but I think most people would rather have a GPU that works. And I guess the upside for NVIDIA is that their boost clock spec is so low relative to the actual operating frequency of the GPUs that it really, like, you can't even blame them for like false advertising. Because if you look at the boost clock for a 3080, like what it runs at versus what it's spec'd at, like even after the the boost nerf with that driver, it still runs way above the rated boost clock. Like it just does. So, yeah. But yeah, so this, and then AMD, like after the 3000 series issues where like the 3950Xs weren't, like the 3950X was sort of the most egregious example of like, hey, this isn't hitting the single core boost like ever. We haven't had that issue since with AMD CPUs. Now you do still occasionally, like I have heard of people getting like, say a 5950X where it won't be stable unless you give some of the cores a positive curve optimizer offset. So it still happens that, you have CPUs that like sneak past the validation, but not to the point that like I've never like that you have NVIDIA going like, hey, if you have a Ryzen CPU and it's crashing in games, go underclock it. Or go restrict the power limits. Like that's just like this is a uniquely Intel situation that we're in here. But this isn't the first example of this. So nothing else. I really hope that Intel like learns from this that look, if you're gonna make a spec, it should be a spec, not a recommendation. Because this is like you shouldn't like if you buy a CPU and you put it in a motherboard, you should like it would be I think normal to assume that it'll just run. Right? Not randomly crash in some all-core workloads. Now, the last thing I want to address is that there's also been rumors of the 13th gen, 14th gen CPUs degrading because of the auto settings being just like complete insanity. Now, I find that very hard to believe because while Intel may be, kind of sloppy with the power limits, I would really hope that they aren't so sloppy as to set the TJ Max and the vid table in such a way that the CPU degrades at 100% load. And the reason I find it really hard to believe the rumors of the 13th gen, 14th gen CPUs degrading on out-of-box settings is that testing for degradation is really quite hard and tedious because you need to first really validate some settings. Like you would need to have this CPU can definitely run X frequency at Y voltage for some, burn really long endurance test. So I don't know, 24 hours of say 5 gigahertz at some voltage. And then maybe 6 months later, you would run that test again at that same voltage, and that voltage has to be really quite minimized. Like that, you can't have like, you know, any safety margin on that. That has to be within like 10 millivolts of what won't run. And so once you have that data of like this frequency at this this is the absolute minimum voltage for this frequency, and then like 3 months later or 6 months later, you can go back and test that voltage test that frequency at that absolute minimum voltage at the same temperature, right? Because if the temperature changes, that'll actually change the voltage requirements slightly. And if you find out that like, oh, these settings that worked 6 months ago don't work anymore, they require 20 millivolts more or 30 millivolts more to work, then it's like, okay, that CPU is degraded. But this is not a test that you really see people do, right? So most of the reports have been like, oh, my Intel CPU was like, it was fine, and then after a few months, it just started crashing and whatever. And it's like, maybe the cool, like that's not a, you know, like it might have degraded, but that's not exactly a scientific proof of like the CPU did X and now it doesn't do X. Because we don't know what it's been doing this entire time. Maybe it's running slightly differently now than it originally was. And yeah. Also on the degradation front, the sort of interesting thing is that you sort of have like, so first of all, I just have a really hard time believing that there's actual degradation, because like, sure, I'll believe that Intel, you know, like we've seen NVIDIA have some issues with, you know, the voltage frequency tables not being quite right, so NVIDIA nerfed it with a driver. AMD had CPUs that weren't boosting quite to where the box said they would boost to, and now we have Intel CPUs that just don't run out of the box because Intel can't be bothered to enforce power limits or whatever. But degradation is like, that's, you know, I find that a much more serious concern than like, oh, the binning, the you know, the binning was a bit loose on the top end silicon. Because that would basically mean that Intel has like no idea what the silicon can actually tolerate, right? If people have 14th and 13th gen CPUs degrading in a matter of months, that means like Intel has absolutely no freaking idea what the silicon can take. Because like the TJ max of the CPU, that like 100 degrees Celsius maximum operating temperature, like the whole point of that is that at that temperature the CPU doesn't degrade. That's the point. And so if the CPUs are degrading at 100 degrees Celsius, that means that Intel is wrong about that max temperature, which is a big problem. Because that's like, you know, because like that's the one thing Intel is actually in control over here. Every Intel motherboard runs the same TJ Max out of the box. That's the one thing the motherboard vendors don't get to play with. And yet, like, if that is not enough to keep the CPU from damaging itself, then like that's a massive problem. Especially since like, so yeah, so that's like, so I find that really hard to believe that actually would be the case. Now, as far as the degradation is concerned, if you want to avoid it, I'd say the best way is to just lower the temperature limit, because there's sort of two flavors of degradation that you get. You have at high voltages and high temperatures, you can have electrons just kind of punching through things that they shouldn't be going through. This is very bad. It will generally kill things extremely quickly. I don't really think that's what's happening here, because that would basically break CPUs, generally speaking. And then the other one is electromigration, right? That's the degradation that sort of everybody knows about. That's caused by very high current draw. It's electromigration is worse at high operating temperatures. And so if you just set a lower temperature limit, like you get at lower temperatures, you get lower electromigration. Also at lower temperatures, like if the CPU thermal throttles earlier, it's not going to be able to pull as much power, right? So you're going to have less current. So that's going to reduce the electromigration as well. And then kind of an interesting wackiness is if you are at that 100 degree current limit, I mean, temperature limit. If you're at 100 degrees Celsius, temperature limit, 100 degrees Celsius at 1.3 volts and 1.2 volts will have different amounts of current draw, right? Because if you have a 300 watt cooling system and the CPU is hitting 100 degrees Celsius, then at 1.2 volts, because the thing is, like, these Intel chips, if you have enough cooling, you can get them to pull like 400, 500 watts. So basically, if you're hitting the thermal limit, you're like, you're not necessarily at the, like, you're not at peak current draw, right? These chips will pull some absolutely insane amounts of current. So basically, if the CPU is thermal throttling at 100 degrees, if it's thermal throttling at 100 degrees, 1.3 volts, that's actually less current going into the CPU than 100 degrees at 1.2 volts, which is kind of a weird thing where, like, you potentially would want the CPU to be thermal throttling at a higher voltage rather than a lower voltage, because at the lower voltage, it's going to be pulling more current. I'm not sure how, like, true that is in this scenario, because again, like, if it's electromigration, then yeah, you would actually prefer it to be thermal throttling at high voltage rather than low voltage. If it's a voltage driven degradation effect where, you know, you just have electrons going through things that they really shouldn't be going through, then you actually want the voltage to be as low as possible. But I don't think that's really like, that shouldn't be a concern at 1.3 volts, or like, and 1.3 volts for a 8 plus 16 E-core C8P, like for one of the 24 core chips, is a lot of voltage. Like, it is a lot of voltage. Even at like 1.2 volts, you can get these chips to pull over 300 watts. At 1.3, you're looking into the like 400 watts plus territory, assuming you have enough cooling. Most people don't. So, yeah. So the like degradation side of it, like that, I really hope isn't true, because that's just a massive fail on Intel's part. Because, like, and sure, Nvidia put out had like issues with cards not being very stable until they nerfed the boost clocks, but they weren't degrading. AMD's put out some CPUs that weren't really hitting the boost clocks that were on the box, but they weren't degrading. We've had laptop CPUs that run at 100 degrees for like years and years and years, and those aren't degrading. And then, like 13th, 14th gen CPU, like high-end 13th, 14th gen CPUs, and it's like, these are degrading? Like, that is like that's just really bad. That's just a massive fail. And so I find it very hard to believe, but that there's like actual degradation going on. I find that extremely hard to believe, because that, like, Intel should know, like, they might be a little bit loosey-goosey on the voltage not being quite high enough to hit the frequencies at 100 degrees Celsius. Okay, fine. We've seen similar things from both from NVIDIA and AMD, but we haven't, like, the chips actually degrading is just like, no way. That to me seems like that's way worse. But let's say you are concerned about the chips degrading, just lower the TJ max. I think, like, that's the most, because at lower TJ max, if the CPU is power throttling, it's gonna thermal throttle earlier, so it's just gonna thermal throttle at lower power draw. The lower temperature alone is going to significantly help with all aspects of degradation, right? That's why if you're on liquid nitrogen, you can run absolutely insane voltages. Like voltages that would at ambient temperatures destroy CPUs basically instantly, and on liquid nitrogen, you can actually run them for a while. Or very long, depending on the specific CPU you're talking about. There's like some CPUs that are like borderline indestructible if they're cold enough. So yeah, if you're like, I find it very hard to believe that there's actual degradation, because like Intel should have very detailed like reliability test data that they have internally. So yeah, but if you're concerned about degradation, the the easiest, most, like, from my perspective, most guaranteed, and I might be wrong about this. I'm not, I don't work at Intel or AMD or NVIDIA. So don't really know enough about this, but if you're concerned about the CPU degrading, lower the TJ max, because that reduces absolutely every factor of degradation that there is, as far as I know. Like every single degradation, like anything related to degrading silicon, can be reduced by lowering the temperature. Would I set the TJ max to 80 degrees Celsius? Probably not, because you're going to give up a lot of performance by doing that. But I think going from, say, 100 to 90, like that alone, if there is degradation, which again, I really do find very hard to believe that Intel wouldn't be on top of that. Even just going from 100 to 90 degrees should help massively. Because it makes a big difference. Like I did a, like intentionally tried to degrade a 3700X, and the fastest way that I could figure out to do it was to run the chip at like 110 degrees Celsius at like very high voltage. And the temperature, like the temperature really does accelerate the degradation quite a bit. So if you're concerned about that, which personally I wouldn't be, but if you are, lower the TJ max. But the thing is, like I know there's people who do like thermal testing with like they test heat sinks and stuff, and they test with the TJ max set to like 115 degrees Celsius, and I don't hear about them burning out CPUs and stuff. So like I really do think the degradation is like, that doesn't seem right. There's probably something else that's causing the CPUs to stop being stable after a couple months. Because if the silicon's actually degrading, that would be a massive fail on Intel's part. As if, like, the fact that they can't even set the voltages at the factory so that the CPUs don't crash wasn't a fail, but like actually having the CPUs degrade, I think that would be like that's like they would like that to me would be like they have no idea what the silicon is capable of taking, right? That would just like completely, like that would, to me, that would mean you would be questioning even the, like everything at that point is like, are Intel's current limits, because they do have current specs, right? Like, is this safe? Because you can't, like, you won't hit this normally. And that would just, yeah. So that's my thoughts on the situation. Is like basically if you lose the silicon lottery on a i9 or i7 CPU for 13th gen, 14th gen from Intel, it might crash compiling shaders. It might crash in Cinebench. It might crash in other multi-core workloads. Chances are it will crash in Cinebench and won't crash in Prime 95, or maybe the other way around. Really depends, like, which specific part of the vid table is not configured quite right. As for how you can fix it, I mean, yeah, you can follow the Intel recommended power limits. If that's not enough, you can mess with the load line calibration to get a bit more voltage under load. Potentially, you could lower the temperature limit. That would also help the stability. So that's all on the like stability side of things. Is like basically the fixes are lower frequencies or more voltage or a mix of both. That like because ultimately when you lower the power limit, it just makes the CPU run slower. When you lower the temperature limit, it makes the CPU run slower. If you raise the voltage and the CPU is thermal throttling, well, if you raise the voltage, it's going to thermal throttle more, so it's going to lower the frequency again. So ultimately, all of these fixes for this instability are basically make the CPU clock lower. And or also reduce the power consumption and temperatures and stuff. And then for the degradation side of things, that I think, like, I would just try to lower the temperature limit. I wouldn't, because the thing is, like, trying to reduce the like electromigration with like at that point you're looking at so much manual tuning that I don't know that that is particularly practical. And like we don't like I don't like is this safe indefinitely? I don't know. You would hope it is. But like yeah, so on the degradation side, I'd say that one, like if you're concerned about it, which I wouldn't be, but if you are, lower the TJ max. Just like go, normally it's set to 100. I'm pretty sure you can set it as low as like 80. I would probably just set it down to like 90. So yeah, that's my thoughts on this. Also, I do not get how Intel isn't aware of this, because as far as I know, like from people who build systems with i9s and i7s, I've heard that like it's quite common to get CPUs where you can't run Cinebench. It just won't run. And so it's like, how does like that's not a, that's not much of a test that you need to do. So like how is Intel incapable of just like taking a Z790 master motherboard and maybe a Hero motherboard from Asus and like a Ace from MSI, like, buy some of these high-end motherboards. Or actually, Intel can probably just ask each of their vendors, like, hey, what's your most popular motherboard? Or like most popular enthusiast motherboard, right? And take those and check, hey, we have 100 CPUs here. Can they run Cinebench on these motherboards on out-of-box settings? And then like some percentage of CPUs won't be able to run Cinebench, or they won't be able to run Unreal Engine or whatever. And it's like, okay, now we can go and figure out why this isn't working. Because as far as I know, this isn't a rare issue. And evidently Nvidia thinks this is common enough that, they need to mention it in their driver patch notes. So like, oh man. Um yeah, so I've said basically everything I want to say about the situation at this point. It's just like the CPUs crash because they don't have enough voltage. The vid tables that Intel is shipping on these CPUs, they don't work at 100 degrees or with no power limit. That's it's kind of that. And so the CPUs are crashing. And the degradation I don't think is actually a thing, because if that is a thing, then like Intel massively failed at like designing the entire freaking platform. Because like at the end of the day, recommended. It says recommended. If the CPU is degrading when you don't follow the recommendations, maybe the recommendations should have been a spec instead of a recommendation. Anyway, yeah, so that's it. Hopefully you found this, I guess, interesting, if not particularly useful. Um, and, yeah, that's it. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, hoodies, posters, the usual YouTuber merch. And I've also got a Bandcamp. There's a link to that down in the description below as well. And that's it for the video, so thank you for watching, and goodbye.